Welcome to the deep dive. If you ever stop and really think about it,
Yeah.
hospitals, they must be one of the most data-intensive places anywhere.
Oh, absolutely. Just an overwhelming amount of information.
Yeah, everything from patient records, medical images, huge files there, right down to, second-by-second vital signs. It's like this constant flood.
A real ocean of data constantly flowing.
Exactly. So the big question we're tackling today, the real challenge is how do we actually use all that data? Not just manage it, but use it to really make healthcare better.
And that right there is where artificial intelligence, especially deep learning, really steps in. It's becoming transformative.
So it's not just helping you out anymore.
No, it's actively making hospitals smarter, more efficient. And for this deep dive, we're drawing a lot from Homera Urizada's work mapping this out.
Okay, great. So our goal for you today, our mission, is basically to pull back the curtain a bit. We want to look at the practical side of AI in hospitals.
Right, how these different tools are actually being used. Things like artificial neural networks, ANNs.
And CNNs for images, right? And RNNs, LSTMs, even generative AI.
Exactly. We'll look at how they're helping with diagnosis, prediction, treatment planning.
And hopefully uncover some, well, surprising things along the way, things happening right now. Should we jump in?
Let's do it. A good place to start is probably with those artificial neural networks, ANNs.
Okay, ANNs. What's the simple way to think about them?
Well, you can kind of picture an ANN as a sort of artificial brain. It has multiple layers, and these layers process information.
Processing information, like patient data.
Precisely. Their main job in healthcare is to sift through huge amounts of really diverse patient data. We're talking age, weight, lab results, medical history, all of it.
To do what exactly? Find connections.
To find hidden patterns, yeah.
Yeah.
Subtle things that might be completely missed otherwise.
So it's not just basic correlations. What's special about what ANNs can find? What's their, superpower?
Their real strength is detecting complex relationships, nonlinear ones, things that standard statistics might just not see.
Okay, can you give an example?
Sure. Think about a patient with type 2 diabetes. An ANN could look at their daily blood sugar, their diet, activity levels, HbA1c results, maybe even family history.
All of that together.
All together. And based on that whole picture, it could suggest a really personalized treatment plan tailored just for them.
That sounds powerful.
And what's really interesting, the source highlights this, is that sometimes these ANNs find connections that, well, they genuinely surprise the medical experts.
Really? Surprise the doctors.
Yeah, it's like finding a needle in a haystack, but the ANN spots a type of needle nobody even knew existed.
Wow. Okay, but if the AI finds something surprising, and maybe we don't quite get how it found it, how does that work in practice for critical decisions?
That's a key question. It really touches on the challenge of interpretability, the black box problem.
Right, understanding the why.
Exactly. And that's a huge area of research right now, explainable AI or XAI. In practice, often these systems act more like very smart assistants.
Assistance to the doctors.
Yeah. They offer insights, flag potential issues, but the human expert reviews it, validates it. It's more about augmenting their intelligence, not replacing their judgment.
Okay, that makes sense. Human AI collaboration. So ANNs handle the numbers, the text data. What about all the visual stuff, the scans, the x-rays?
Right, that's a huge part of medicine. And for that, we turn to convolutional neural networks, CNNs.
CNNs, they're the image specialists.
They really are. Think of them as having like built-in vision. Different layers in a CNN act like filters.
Filters. How so?
Well, early layers might spot simple things, like edges or corners in an image. Then deeper layers combine those features to find more complex stuff. Like the specific texture of a tumor or the telltale signs of a tiny fracture or a bleed on a CT scan. They learn these visual patterns.
So they can spot things on scans very accurately.
Incredibly accurately, often faster and sometimes more consistently than the human eye, especially for subtle things. Early detection is a big application.
Okay, and the article brought up something really fascinating related to the digital twin. That sounds pretty futuristic.
It does, doesn't it? But it's a very real concept now, built using these CNNs and image analysis. Kind of an aha moment.
So what is it exactly? A virtual copy?
Pretty much. It's a precise virtual model of a patient's specific organ, say their heart, built directly from their detailed medical scans, like MRIs or CTs.
A virtual heart based on my heart scans. What's the use case for that?
Imagine a complex surgery. With a digital twin, the surgeon can actually simulate the procedure beforehand. They can plan every step, test different approaches.
Practice on the virtual model before the real thing.
Exactly. Choose the absolute best way to do it, tailored to that specific patient's anatomy. It's huge for planning complex operations.
That sounds like a massive leap for patient safety, especially in tricky surgeries.
It really is. The potential is enormous.
But what are the challenges? You mentioned computational power.
That's a big one. Building these super precise, high-fidelity models takes a lot of computing power and very high-quality scan data.
So it's not quite routine for every single procedure yet.
Not for everything, no. But for those really complex, high-stakes surgeries, it's becoming a game changer. The upfront effort pays off in reduced risk and better outcomes.
Okay, so we've covered AI, looking at static data, numbers, text, images. But patients in hospitals, especially ICUs, their condition changes constantly, right? Vital signs going up and down.
Yeah, that dynamic data is another big challenge. How do you monitor and predict changes happening in real time?
So how does AI handle that flow of data over time?
For that, we look at recurrent neural networks, or RNNs.
RNNs, what's special about them?
Their key feature is memory. They can remember information from previous time steps.
Memory, like they recall what happened a minute ago.
Exactly. And they use that memory when processing the new data coming in. Think about understanding a sentence. You need to remember the words that came before to get the meaning right.
Okay, yeah, that makes sense. Context matters.
Precisely. So RNNs are great for continuously monitoring things like heart rate, blood pressure, oxygen levels, and watching the trends.
And what's the impact? What can they do with those trends?
They can spot dangerous patterns developing, and crucially, they can often predict a potential problem and raise an alert before the patient's condition actually becomes critical.
So like an early warning system, okay, but driven by the data trends.
A very vigilant early warning system, yes. And building on that idea, the source also mentions LSTMs.
LSTMs, long short-term memory networks.
That's right. They're basically an enhanced type of RNN.
Enhanced how? Better memory.
Essentially, yes. They have a more sophisticated memory mechanism. It's better at holding on to important information for longer periods.
So standard RNNs might forget older stuff.
They can sometimes struggle with very long sequences, yeah. New data can kind of overwrite the older memory. LSTMs are specifically designed to combat that.
So they can remember patterns over months, years.
Potentially, yes. That makes them really valuable for analyzing chronic diseases, or tracking how a disease is progressing over a long time, or seeing long-term effects of treatments. They can connect the dots over much longer timescales.
That's incredibly useful for long-term conditions. Okay, so we've seen AI analyze, interpret images, predict trends. But there's another type of AI getting a lot of attention lately. Generative AI. How does that fit in?
Right. Generative AI is a bit different. It doesn't just analyze existing data. Its main function is to create new data.
Create new data? Like what?
Data that looks very similar to real-world data. A key example uses something called generative adversarial networks, or GANs.
GANs. What can they generate in healthcare?
They can create incredibly realistic synthetic medical images.
Artificial medical images. Why would we need those?
Think about rare diseases. It can be really hard to get enough real patient images to train doctors or even other AI models.
So GANs could create, say, artificial lung scans showing a very rare condition.
Exactly, where real examples are scarce. These synthetic images are super valuable for training, for simulations, for research.
That's a clever application.
Yeah.
What about other generative models, like the ones that handle language, like GPT?
Good point. Transformer models, like GPT, are powerhouses for natural language processing, NLP.
And in a hospital, what can they do?
Lots of things. They can help automatically write draft medical reports, summarize long research papers, even pull key information out of messy handwritten doctor's notes.
Wow, extracting info from handwriting, that alone sounds useful.
It really is. Think about how much time doctors and nurses spend on paperwork. This kind of AI can significantly cut down that burden of repetitive writing and admin tasks.
Freeing them up for actual patient care, that's a huge potential benefit right there.
Definitely.
Now, the article also mentioned a specific system. I think it was called the TR system. How does that connect all these pieces?
Yeah, the TR system is a great example of how the real magic often happens when you combine these different AI tools.
So it's not just one type of AI, but several working together.
Exactly. The TR system, for instance, combines statistical methods like regression with neural networks, different tools bringing their strengths.
And what does it achieve? What's its remarkable feat?
Its big achievement is detecting septic shock. That's a really dangerous, fast-moving infection response.
Okay.
And the TR system can often detect the signs hours before clear clinical symptoms are even obvious to doctors.
Hours before. That's incredible. That must make a huge difference.
It's a massive head start for treatment. It allows for those crucial early warnings, which can be life-saving.
Wow. So that really shows the power of synergy, bringing different AI approaches together.
It absolutely does. It underscores the kind of profound impact you can get when these tools don't work in isolation, but as part of a more comprehensive intelligence system.
So if we're boiling this down for you, our listener, what's the main thing to take away about AI in these smart hospitals?
I think the key takeaway is that this isn't science fiction anymore. These AI algorithms aren't just theories or lab experiments.
They're real working tools,
Exactly. They are tangible tools working behind the scenes right now in hospitals, and they're making a concrete difference.
like improving diagnoses.
Definitely increasing diagnostic accuracy, yes.
Yeah.
Enabling more personalized treatments, like we discussed, and also freeing up staff from some of those repetitive tasks,
Letting them focus more on the patients.
which ultimately makes hospitals more efficient, safer, and, well, smarter.
So even if we, as patients or visitors, don't directly see the AI, it's there fundamentally changing how things work.
It's an unseen revolution in many ways,
Yeah.
quietly transforming healthcare information and decision-making.
Which brings us to a final thought, maybe something for you to ponder. As these AI systems get better and better,
Generating realistic medical data, making complex diagnoses, even writing reports. How does that change things? How do we ensure that the human element,
empathy, clinical judgment, ethics.
right, how do we make sure those stay absolutely central to patient care, even as the technology gets more powerful?
And here's another thought. What happens when AI, or maybe your own digital twin, holds more predictive information about your future health risks than you do yourself?
That opens up some fascinating questions about knowledge, privacy, and decision-making, doesn't it? Definitely things to think about as this technology keeps evolving.